Hello, and welcome to another episode of Maths in an Empty Classroom with me, Mr. Southern. This video is on probability tree diagrams, and there's a conditional probability element in there in part B. Okay, so we've got this scenario here. Pat travels to work by car, often gets delayed at 3 roundabouts. The probability that he is delayed at the first, second and third roundabouts is 0.4, 0.6 and 0.7 respectively. We're being asked to find the probability that he's delayed at all 3 roundabouts and then exactly 1 roundabout. Now, just all 3 roundabouts, we can jump in straight away there because we can just multiply the 3 probabilities together. What I am going to do though is set it all out in a nice tree diagram because that's going to allow us to access the rest of the question. So the first event is roundabout 1. I have either being delayed or not delayed. The probability of being delayed is 0.4 and not being delayed is 0.6. Second event is roundabout 2. I have probability being delayed and not being delayed, which is 0.6 and 0.4, and then the same on the other set as well. And then I have the third roundabout, so I've got final branches coming off all of these of being delayed or not delayed. Delayed or not delayed. Hang on. It's inevitable. There we go. Delayed or not delayed. Delayed or not delayed. Probability to be delayed at the third one is 0.7. So not being delayed 0.3, and it's going to be the same all the way down. Okay. So, probability of being delayed at all 3 roundabouts, I'll just do that bit up here, which is 0.4 times 0.6 times 0.7, which I think is 0.168, but I'll just give it a check. Yeah, 0.168. Okay. For the next one, delayed at exactly 1 roundabout, I'm just going to inspect the tree diagram to determine which of those events that I'm actually interested in for part II. So being delayed at exactly 1 roundabout. So if I'm delayed at the first one, I can't be delayed at the second or the third, so that's that one. If I'm not delayed at the first one, I could be delayed at the second but not the third, so it's that one. Or if I'm not delayed at the first, I could be not delayed at the second but delayed at the third, so it's that one there. So working out the probability of each of those 3 events separately and then adding them up will find the overall result. So 0.4 times 0.4 times 0.3, which I think is 0.048, but it's always nice to check these things. Yeah, 0.048. Second one we've got 0.6 multiplied by 0.6 multiplied by 0.3. 0.108, yeah, 0.108. And the final one, we've got 0.6 multiplied by 0.4 multiplied by 0.7. Which is 0.168. Okay, so probability to be delayed at exactly 1 roundabout is the sum of those 3 possible ways of it happening. So I'm just going to quickly do that now, and you get 0.324. Okay, part B, this is the bit where the conditional probability starts kicking in. So Pat was delayed at the 3rd roundabout. Find the probability that he was also delayed at the 2nd roundabout. So Pat was delayed at the 3rd roundabout. Let's just think about which outcomes that is. Well, it's any one that he's delayed at the 3rd roundabout. So it's those 3 and that one again. So what I'm just going to do, I'm going to do this in purple. So I'm just going to work out these probabilities being delayed at the 3rd roundabout. So we've got 0.168 there, we know that from before. Here we've got 0.4 multiplied by 0.4 multiplied by 0.7. Which is 0.112. Here we've got 0.6 multiplied by 0.6 multiplied by 0.7, which is 0.252. And I need to include this one as well. So he was delayed at the third roundabout. That's like saying given that he was delayed at the third roundabout. Now what that means is that my probability for part B is going to be out of that probability of being delayed at the third roundabout. So I'm going to sum up those four values. So 0.168 plus 0.112 plus 0.252 plus 0.168, which is 7/10, 0.7, that's nice. That makes an awful lot of sense, doesn't it? Never mind. So find the probability that he was also delayed at the second roundabout. Now we need to think about, in these four scenarios where he was delayed at the third roundabout, which of them also included him being delayed at the second roundabout as well. Right, so delayed at the first, delayed at the second, delayed at the third. So we want this one. Here we've got delayed at the first, not delayed at the second, so we don't want that one. This one here we've got not delayed at the first, delayed at the second, delayed at the third, so we do want this one. And this final one here is not delayed, delayed, so we don't want that one. So on our numerator, we want the two outcomes where he was also delayed at the second roundabout, which is the 0.168 plus the 0.252. So 0.168 plus 0.252, which is 0.42. So we end up with 0.42 over 0.7, which comes out rather beautifully as 3/5. So the probability that he was delayed at the second roundabout, given that he was delayed at the third roundabout. We did the probability of being delayed at the third roundabout as the denominator, so that was what it was out of. And then these two were the probability that he was delayed at the second roundabout, but only choosing out of the ones where we already knew he was delayed at the third. So a bit of conditional probability on a tree diagram there, and that's how they all work. Thanks for watching.